So, panel 5, responsibility and communication. Unfortunately, Bert Gordijn is not coming, so we have 4 speakers. I would say approximately 10 to 15 minutes for each presentation, and then debate. This is a crucial topic, needless to say, it is a crucial one. When it is about responsibility in communication, it is about many things we are used to, such as fake news, false hopes, but it is also about something more, I would say. It is about enhancing, promoting people's ability to deal with an ever more complex context, background of technical, scientific opportunities. What we have the possibility to do and what we should do or not do. And information is crucial. It is a pivotal issue for democratic societies. So we have different points of view, different professional background here, not around the table, but at the table. And the first one to have the floor is my friend Maria Doceu Patrão Neves, full professor of ethics, University of the Azores, president of the National Ethics Council for Life Sciences in Portugal, vice president of the European Group on Ethics in Science and New Technologies of the European Commission. Maria is member of the UNESCO World Commission for Ethics in Scientific and Technological Knowledge, COMEST, the Steering Committee for Human Rights in Biomedicine and the Health of the Council of Europe and the Lisbon Academy of Sciences. She was a consultant on the ethics of life to the President of the Portuguese Republic and a member of the Board of Directors of the International Association of Bioethics. Is that enough, or?
That's already a huge responsibility.
She also was a member of the European Parliament.
Oh, yes.
Maria, you have the floor. 10 to 15 minutes.
Okay. I have a chronometer here that is. Wait. Okay. Do I have? Yes. Thank you so much. So, I would like to start by expressing my deepest gratitude for the honor of this invitation, and I must say also for the privilege to take the floor or the table before you, and most of it to have. I mean, I had the opportunity yesterday and today until now. To listen to you all, and it's been a wonderful meeting with so much information, so many different perspectives about issues that we care about. So thank you to all of you. I'm going to talk under this inspiration of the birth of new man of Dali, just focusing on the egg. The egg is the symbol of hope, renewal, the future. So that's why I chose this image, although I'm going to start by going back to the past and tell you a story of my own life. It was many years ago, and clinical trials in gene therapy had begun to develop in the 90s, generating great enthusiasm. At the time, I was a postdoctoral researcher in a course at the Kennedy Institute at Georgetown University, led by a professor who was a specialist in genetic technologies and who chaired advisory panels on human gene therapy. You know already who I'm talking about, but I will not say it. His question that day was the following: what would each of you like to enhance in yourselves through genetic engineering? My colleagues multiplied their wishes. many of them focused on cognitive domain and especially on memory. I hesitated, but when my turn came, I said immediately that before seeking to acquire what it did not constitute me, I would prefer to realize more fully what I already was. So I would say that the question of the quiz was already, for me, decisive and even conditioning of the quiz. What I can become, the characteristics I may develop or acquire through biotechnologies, should follow from who I am, who the human is, so that one may become more and better without alienating one's identity. So it's taking this old idea from the 90s that I'm going to talk to you today, just pointing out three main ideas. The first one, going from the quiz to the quid, who we are and what ought to constitute us, that we may fully be. Then from the hypothesis of strengthening and improving our characteristics to the risk of suppression of who I am, of my own identity. And the third point about how can we balance both, to be faithful to who I am, but at the same time to benefit from what new technologies can offer to me. I think this is the role of major national and international institutions, that is to find this balance between innovation and embedded them in ethics and have them be driven, orientated by responsibility. So let's start from the beginning. It's always a good option to start from the beginning. So from who I am to what constitutes us or can constitute us. And here I would say that the first question that immediately pop up is the criteria. The criteria that we use to select the technologies that we are investing on. Which technologies do we want really to be developed, to be designed, developed, implemented, and used? And the first criteria is quite easy, is the one that is really consensual. I mean, it has a therapeutic purpose, so it's good. Yes, because health and life, we consider them as good in themselves. So I want to protect health, I want to preserve life, and if this new technology can help me on that, it has a therapeutic purpose, so that's fine. Let's go for it. Well, the question is not that easy. That's why I need my 10 minutes. And why? Because listen, what we know nowadays is that it's not that easy to have a sharp cut, a line separating therapeutic purposes from enhancement, because we know that there are so many technologies that have both purposes. I mean, if you take gene therapy, for instance, or gene editing, sorry, you can use it to correcting some mutations that are responsible for genetic diseases, but you can also use it to build resilience, changing genes to build resilience to specific diseases. So in this second case, is it a therapeutic purpose? Yeah, but isn't it also enhancement? Yeah, so what? So it's not that easy, really. So what we can say is that once this line between therapeutic and enhancement fades away, this purpose of the therapeutic purpose becomes less important. Besides, we also know that the very same technology can have a dual use, so you can use it for different purposes. So if the technology exists, it becomes much more difficult to manage and to control its different uses. So again, what we do in this case, I would say that under these conditions and without the possibility of a clear distinction between therapeutic and enhancement purposes, without a clear criteria for selecting and implementing, because I need a criteria to know in which technologies I want to invest, without having the therapeutic purpose as a strong criteria, I have to move on to other kinds of criteria. So I would say that if we start from the quiz, as you see, to the quiz, the purpose is really the main criteria. But if I go a little bit further and I inverse the sense, I start by the quid, that is, the existing technologies to preserve our identity, I need another criteria that is not purpose anymore, but is mostly the impact that the existing technologies can perform when they are applied. So what kind of impact am I talking about? Of course, this is everything very simple because I just have a few minutes to talk about this. So let's just make a distinction between, quantitative impact, that is one of degree, and qualitative impact, that is one of nature. And here, again, things can become quite tricky, quite complex. I would say that because it's not really easy to know what kind of impact it's going to play, and the risk of denaturalization comes from a qualitative impact. So the tendency, once we have the technology, is to say that if you take the principle of autonomy, you can use it, regardless the fact that it's therapeutic or for enhancement purposes, you can just use it. Of course, that if you are focusing on the principle of autonomy, you will say, okay, you can use it, but only in your own person. So it doesn't matter either if it is therapeutic or enhancement, if it is a qualitative or a quantitative impact, because it will be confined to you. It will not alter the species. Of course that it raises many other problems, such as social justice, discrimination, well, so many others that perhaps we can talk later. But at least under this principle, we can confine it to one individual. Totally different is the other hypothesis that we talked about yesterday quite often, that is this transhumanist or post-humanist view that says that if the technology exists, you should use it as much as possible to improve yourself, the species, everything, and create another species. Why not? That if it is better than us. I don't know if it is artificial intelligence or what else, but one thing that I want to stress is that our humanity is shared by all of us, is universal, a universal inheritance, and we are their keepers. So we cannot arrogate the right to change the next generation. Not even, yesterday we talked about children, to design our own children. I mean, who is so arrogant that decides who the others should become? 10 what? I'm sorry, but I'm going to almost to my last slide, so listen, they are disturbing me. I need more minutes.
20 seconds more.
Okay, great. Let's profit. So let's go. I went from the quiz to the quiz, from the quiz to the quiz, saying that we need different criteria. But what is really of paramount importance is to balance both. I mean, that's what I said since the very beginning. So we need to be faithful to our own identity, but we cannot neglect the benefits that we can receive from biotechnologies. So here I would say that we need, first of all, to raise awareness, to foster dialogue, so we can build an ethical consensus that is going from bottom up. So we start from the bottom, we create, through inclusive dialogue, we create a consensus, we go from bottom up, we go to the top, and then we have the law giving force to the ethical consensus, and we have top down. So we have constantly to go bottom up and top down. And having this in mind, then we can address the question of regulation. Of course, that we know regulation is not a great word today, is almost forbidden, but still, and in the name of being more competitive and so on and so forth, let me go immediately to my last point. Regulation is needed. We need regulation not to stop innovation. We cannot stop, we should not stop technological innovation, but we do need a balance between technological innovation and the common good. And the only way to do is through regulation, because otherwise the benefits of technological innovation will be captive by the most powerful ones. And what we need is to have equal access to the benefits of technological innovation. So, finishing. I would say that really regulation is the only path today to secure the benefits, that is the quiz, without endangering our identity, that is the quiz. So ethically grounded regulation is really needed, and it's our way to keep the quiz at the service of the quiz. That's what I would like to say. Sorry, I forgot to click on this device. So keep the quiz at the service of the quiz, rather than allowing quiz to become an object or a mere raw material for the quiz. Thank you so much.
Thank you, Maria. I think this is a first path towards the recognition of the crucial role of communication. We need regulation through ethical and social consensus. This means and implies that we have to get to regulation through communication and debate. Building on sound information and open relationships. Now a second path, I think, to the same goal. This is the professional path, the more professional path, I would say, in the sense of the communication professional community. Luigi Ripamonti. I have to change my glasses. Sorry. Luigi Ripamonti is the editor-in-chief of Corriere Salute, the health section of Corriere della Sera, the main Italian newspaper. Before becoming a scientific journalist in 1992, he worked in the medicine pharmacology department of the University of Milan, where he graduated in 1986. As medical scientist, he was involved mainly in the fields of the antimicrobial resistance and of the relation between antibiotics and the immune system. He has taught a seminar on medical or scientific journalism for several years at the University of Milan, and has delivered lectures at George Mason University, Virginia, and Chapman University, California, and Catholic University of Milan. Currently, he teaches in several postdoc masters, San Raffaele University in Milan, University of Parma and of the Marche, and is director of the Health Management Masters Program at LCS Academy of Corriere della Sera. Luigi, the floor is yours.
Thank you. Can I?
Yes, sorry.
Well, thank you. First of all, I want to thank the organizer for inviting me again to this such important meeting. It was a mistake, of course, but now I'm here. Second, I beg your pardon for my English. Third, and main problem, all the things I was going to say, said better from Maria, so I have nothing to say. But anyway, I will be very short. Anyway, well, the point for me is this. What kind of challenges does a journalist like me faces in the era of synthetic biology? Because the arrival of this new player in the information landscape changed the rules and propose new, fresh challenges. The first challenge is to try to maintain in scientific integrity in our story, despite the growing complexity of the field. And the second problem is to keep on responsibility about the philosophical question that raises this new arrival, philosophical question that impact on civil and political field, also if this field are not directly implied in our stories. But this creates a problem. Well, first challenge. When we began in the earliest days of this century to began writing about genetic engineering, essentially we were writing or speaking about modifying something existing, cut and paste DNA. Moving from this paradigm to the new paradigm of synthetic biology is manufacturing something as Nilo is not just a technical step for us, is a full change of paradigm, is a giant leap. And the problem to jump in the quid trap is for us is important. It's very difficult. So we have to pay very, very much attention to don't use modification narrative, but use fabrication narrative. It's it's a challenge, of course. And another problem. We can be tempted to use misleading simplification in our stories, just to be understood. Well, but if we avoid to explain in the right way, to grasp and then explain key differences in method, we try to do very, very big mistakes. If we don't understand the difference, in example, from emptying a cell and filling it with custom DNA, an example, or in the contrary, building biobricks from ex nihilo, well, this is of course top-down and bottom-up, or again, DNA synthesis, assembly sequences without a natural physical model. We run the risk to do something very, very, very bad because precision matters in this way, absolutely. And so, another going on. One other problem for us is to be very, very careful in using metaphors in order to be understood. It's handy to say cell is a hardware, DNA is a software. Okay, everybody can understand it, but is it dangerous or not? Yes, it's dangerous if I don't take the context in the right way, because in this way I say that life is a program. Okay, and if I say the life is a program and that's it, I fall in a reductionist way, in reductionist view. Sorry, and I don't. If I don't take into account that about what is life, what is consciousness. We have seen yesterday a lot of interesting lecture about it, and I don't take account that there is a big debate about this kind of concept. well, I don't do my work in the right way, in the honest way. Yes, I gave you some example just to say something. Monism, vitalism, dualism, skepticism. If I don't take into account this, and I pick up the one I prefer, or the majority the opinion of the majority, I'm not neutral. I'm doing a choice in ethical and in political way. So pay attention. And another problem is what I have to ask to myself in front of an invention, a biological invention. Have I had to ask it to myself just, does it work? No, it's not enough. I have to ask to myself, what is this value in a broad context? Otherwise, I fall in a quid trap. I'm not asking the difference between quiz and quid, and we saw yesterday very good during the lecture about Colossus and about nucleus. Okay, it works maybe, but is it a value? I wonder. I have to wonder, of course, and this goes to another problem for us. If I don't take into account all this problem, I fall to educate the readers. I mean, I remember I give an example. Last year here in this conference, I was very impressed by a lecture, by a debate about the legal right of neuroorganoids. Laura Palazzani probably remember it very well. At the first glimpse, I asked myself, what's the matter if a group of cells has not a right? But I did understand that the problem was not that group of cells. What coming next? More complex, more structured, and at the end of the day, us, of course. So I want to stop here. The problem is that the journalist should be a custodian of meaning and not just a reporter of facts. Thank you so much.
Thank you, Luigi. Less than 10 minutes. Well, I think that there is no one who doubts about the importance of Luigi's presence and contribution here at the table. In particular, I was really impressed by the open words you used to bullet point the journalist's duties. We are much more used to bullet point rights, maybe challenges and open questions. You're reminding us about duties of a professional community is a very, very crucial and useful approach, I think, to the so relevant issues we are debating during these days. Thank you very much. And then John Ioannidis. John Ioannidis is Professor of Medicine and of Epidemiology and Population Health, and by courtesy Professor of Biomedical Data Science at Stanford University, and one of the two directors of the Meta Research Innovation Center at Stanford that focuses on evaluating and improving research practices. John Ioannidis has a long-standing track record in theoretical, empirical, and applied research in research methodology ranging from clinical trials, observational epidemiology, molecular and human genome epidemiology, prognostic models and predictive medicine, and translational research. His current citation rate makes him one of the 10 most cited scientists in the world and the most cited physician. He has received numerous awards and numerous honorary doctorates and has been inducted in numerous election-based academies. His work on research, credibility, and reproducibility, which I think is the topic you are focusing on, has attracted wide attention across very diverse scientific fields and is commonly taught at diverse educational curricula worldwide. He has successfully trained many young scientists at the doctoral and postdoctoral level, who currently hold faculty and senior investigator appointments in the USA and in diverse other countries throughout the world, which is one of the tasks to perform for a university professor and a scientist. So, John, the floor is yours.
Thank you for the very kind invitation. It's a great pleasure to be participating in this conference. I feel that I have already learned a lot and stimulated with very interesting ideas that have been shared. So I will focus on science, because so far we have been discussing about communication and responsibility, which is important, but we take for granted that science, evidence, scientific evidence should be a solid basis. So I would like to create some uncertainty around that as a scientist, as a failing scientist, on a daily basis, realizing that what I do is full of errors, of trying to improve and self-correct. Some preemptive comments. Science is really great, knowing information, knowledge, wisdom that was mentioned in the previous panel is ideal, perhaps the best thing that can happen to us. But most science to date is using non-reproducible and suboptimal research practices. Science is becoming very massive and very complex. There's more than 40 million people who have authored scientific papers in journals that are considered to be very legitimate and to be linked to standard databases. We have more than 200 million publications already. They are increasing at a rate of more than 8 more million every year. And most of them are advertisements, a bit like religious trust, and belief. Trust me, I did this research. I resurrected that person. Data? No. Code? No. Protocol to be registered? No. So probing the credibility of this massive information is not easy, and public trust in science had typically been very high because we saw progress, we saw humanity making advances, but in recent years it has sharply decreased among many segments of the community. Why? Well, I think that there's valid reasons. I mean, it's not just crazy people who lose trust in science. First of all, science has been highly commercialized. People see that science is a way to make money or is hijacked to make money. There's real and perceived conflicts of interest, very strong partisanship and ideology permeating a lot of the science that we do or that we report or we try to interpret. Political interference has become very obvious and very dominant, both from left and right and center and everywhere. Activism, well-intentioned perhaps, but an activist has an orthogonal dimension versus the scientific approach. If I'm an activist, if I'm wrong, I will still be an activist. If I'm a scientist, I'll go against that which I believed before if I find out that I'm wrong. Lack of transparency, as I mentioned before, and an overall challenge to the Mertonian values of science, disinterestedness, communality, universalism, organized skepticism. They seem to not be relevant for the science that surrounds us most of the time currently. This is a paper I published 2 weeks ago. It's a very simple analysis. I just took the Economist ratings of democracy or lack of democracy in the world and the Reporters Without Borders about freedom of the press around the world. So, Robert Merton and traditional sociology of science can only flourish in democratic societies with freedom and press, and you can say and think and do whatever you believe. Currently, about 80% of scientific papers are published from countries that are not full democracies. 92% of the papers are published from countries that don't have good freedom of the press. Countries that are not full democracies include now the United States. Countries that don't have good freedom of the press also include the United States. They include many European countries. The country that I grew up and spent much of my life, Greece, currently, I think is a full democracy, but its freedom of the press is worse than many African countries. China is publishing more than 2 times the number of papers of Europe or the United States, and the gap is going to grow even bigger. And India will catch up the United States within a few years, like 3 years, to become number 2 in productivity. Fake fraudulent papers are just the tip of the iceberg. 20 years ago, when I published a paper on why most published research findings are false, people were asking me, so you mean there's fraud in science? And I always, no. Why should the sciences be fraudulent? You trained for 300 years, and you get a salary that's worse than if you were to become an electrician, technician, whatever, and become a fraud for that? No, fraud is not the issue. It's technical, statistical, analysis, design, methodology, whatever. I will not respond the same now. I think that fraud is very common, and it's an estimate that in 2026, about 10 to 15% of papers published in seemingly legitimate journals are mostly paper mill, AI products, completely fake information. Public government proportion of R&D. Supposedly, if it's public, it's unconflicted. That's what I thought. No, not really. Not at all. But okay, I think it's probably at a starting point of less conflicted compared to I'm paying you to get the result that I want, okay? In 2005, it was 40%. In 2026, in the United States, the leader of high-impact research is 20%, assuming that no cuts are implemented, and we've survived so far, but if the originally proposed cuts had been implemented, it would have been 10%. Institutions with the highest computational capacity, within 20 years, academia lost completely in the competition. Right now, 10 of the top leaders are industry tech. Some of them are next door to my campus at Stanford. We have Google, we have Meta, we have all these deal giants. Stanford supposedly has the highest computational capacity than any university. It's a tiny little piece compared to the computational capacity that they have. Biases were always around in science. The good thing about science was that science could recognize biases, identify them, preemptively try to get rid of them, or at least correct them after the fact. This is a text mining exercise I did many years ago. We identified 235 biases that could recreate the map of science itself, depending on what attention was given in different scientific fields. But now we have a new beast. We have very different types of problems. Most publishers, at least serious ones, have started using software to try to detect whether papers are entirely fake. Wiley released data about a year ago that about 1 in 7 submissions, if you translate that to 8 million papers, that would be more than 1 million papers every year would be fake products of AI. And that was 1 year ago. Currently it may be far more, and there's no reason that it would not be more. Even for the most rigorous types of research, which I would say is randomized controlled trials. Why? Because they need to be visible. They need to go through regulatory checking. They need to go through IRB, ethics committees. They involve many investigators, lots of rates of review. They're registered in clinicaltrials.gov. Everyone is seeing them. Well, John Carlisle, the editor of Anesthesia, a very prestigious journal, was kind of suspicious. So he started asking people, please send me the raw data if you want to submit a randomized trial to me. He concluded that 40% of the trials submitted to a prestigious journal were either completely fake or so wrong that it would be better if they were just fake. So he called these trials zombie trials, and on a Halloween day, I published this editorial very appropriately to accompany his work, suggesting that if what he saw in a prestigious journal applies across medicine, then we have about 500,000 zombie randomized trials circulating among us and informing our decisions about what is good, what is effective, what is failing. That's very minor problems compared to the most major problem that we have now, which is that science is becoming irrelevant. In the AI era, in the technology era, perhaps nobody would care about science, about scientific journals. And this is an early precursor. In 2015, I wrote the first negative paper about Theranos, which was the highest valuation startup company at $9 billion, getting honorary doctorates for their CEO, front page, and all magazines, the future of health, the future of innovation, the future of disruption, changing everything in medicine. I looked at what they have. They were publishing nothing in the scientific literature. So that was stealth research. They were proud of it. We will disrupt everything in health We don't need to publish anything. So I said maybe their valuation should be $9 instead of $9 billion. And of course, their general counsel did not like that and got in touch with me. But now their valuation is $0 because it was all fake and they had really nothing to show. But Theranos is not just a single bad apple. We looked at all digital health and any type of health startups. Half of them publish nothing or next to nothing. They believe in stealth research. Recently, we're looking at the top startup companies for AI and LLMs. Most of them publish absolutely nothing. They don't care about publishing. You know, a few would, you know, like, Demis Hassabis, a great scientist, also Greek origin. Let's publish a couple of papers in Nature, let's get a Nobel Prize, and, just out of fun. But we'll mostly make money. I mean, that's what we are here for. AI is increasing the dark matter of research production. As I said, universities, traditional institutions of learning and of research are currently just tiny, tiny contributors in computational space, in energy consumption space for intelligence. Most AI research is growing outside, perhaps, the scientific literature. It may or may not be open source. Even if it is open source, one day Alphabet may say, now it's closed source. Thank you for giving me all your information and all your data. So long. I'm going to use it to make more money. Is more application, more rigor, more efforts to confirm the answer? I have struggled for that, and many others have struggled for that. 2 days ago, the SCORE project released a massive 3 papers in Nature and 5 preprints, 900 scientists trying to analyze diverse papers and studies across science. This is an early precursor, the Reproducibility Cancer Biology Project. Most papers, most highly cited papers, even if you ask the authors, even if you get in touch with them, you cannot repeat them. You cannot even get them started. You cannot understand what they did. You ask them, they say, still, you cannot get it started. If you do get it started, about 2 out of 3 times, they will not replicate. You will get a very different result. Openness, yeah, we have improved openness from 0% practically 20 years ago to about 20% at the moment for data, to about 6% for code, to about 7% for protocol. Almost everyone still says that we're generating innovation, innovative science, progress. No, not really. Science is no longer disruptive. All indicators of disruption, if you look very seriously, science innovation is going down, steeply down. Disruptive papers are very, very uncommon in that mess. If you ask for both data and code and protocol, good luck. Less than 1% of papers will give you that. And among those, half of them, you will get a different result if you try to do it again. Computational methods, that is the basis of all that new revolution of AI and everything. They're so complex at the moment that even specialists cannot make sense of them. We tried to put some obstacles to the dissemination of dark matter in that area. This is a paper we published many years ago in Science. They haven't worked. I think that currently AI can do anything. It's dark box, it's just black box. Performance and benchmarking are highly flawed and highly biased. You can easily spread any sort of misinformation with very complex AI technology. You can maximize inequalities, destroy societies, disrupt the scientific ecosystem, not in a positive way, replace me and all of us with AI agents, ethical issues, much better than me, and many, many broader issues. We will review all of that. Well, we had our peer review congress a few months ago, many ideas about how to use peer review to stop that flood. None of them works very well. I'm not saying to dismantle peer review, but probably peer review now will be done by AI. Editors will be AI. Peer reviewers will be AI. AI will recommend AI or oppose other AI. All right, to conclude, scientific literature, massive and expanding fast, but its credibility and relevance needs to be revisited continuously. Reproducibility indicators, sharing, openness, transparency, reproducibility, accountability, nice, yes, of course, but they're surrogates. And what matters in science, in research, the positive impact is far more complex. There's new stakeholders out there and new ways of doing and publishing science that may change very fundamental notions about what the scientific literature is, what it represents, whether it's worth it, even to communicate, let alone to be responsible for it. Thank you so much.
John, it is very difficult for me to resist the temptation to anticipate a very humble question. Is there any hope left?
Well, I haven't committed suicide yet, so unless I am an LLM and I'm fooling you while talking, which now is a real possibility. You know, the technology is good enough that I could have been an LLM talking to you, and no one would recognize.
Thank you very much. And now our last, not least speaker, Catarina Monteiro Gomes. Catarina is a biomedical engineer and postdoctoral researcher at the Department of Biosystem Science and Engineering of the Eidgenössisch-Technische Hochschule Zurich, based in Basel, Swiss Federal Institute of Technology, Switzerland. She holds a PhD in bioengineering with a specialization in cell therapies and regenerative medicine from Universidade Nova de Lisboa and Instituto de Biologia Experimental e Tecnológica in Portugal. Is it okay? Where a doctoral research focused on the development of immunocompetent three-dimensional human central nervous system models for preclinical gene therapy applications. Her current work is conducted within a collaborative academic industry project between ETH Zurich and Novartis Pharma AG, where she investigates the selection and screening of brain-tropic viruses using complex brain in vitro models. Previously, she held research positions at IBET, contributing to the development of stem cell-derived 3D models and scalable bioreactor systems for cardiovascular, neuroinflammatory, and neurodegenerative disease studies. Catarina has presented the research at numerous international conferences and has received different awards for her presentations. Her work has been published in peer-reviewed journals spanning biotechnology, bioengineering, and in vitro disease modeling, with a particular focus on 3D cell culture system, brain models, and translational preclinical assessment. She is also actively engaged in mentoring and initiatives promoting gender equality in science, including her involvement with Soapbox Science. Catarina, the floor is yours.
Thank you so much, and I must say that the pronunciation was fantastic on point, so thank you so much for that.
I'm trying to improve with Portuguese.
That was fantastic, thank you. So first of all, I would like to say how thankful I am to the organizing committee, and with a special shout out to Ralph for inviting me. It's a great pleasure to be here, and I must say that I'm particularly humbled to be at this table with many many specialists in their own areas, and it's really humbling. And I'm actually not going to say anything new. It's very hard to follow John's talk on this, but hopefully I'll be able to show you one particular example where I think that scientists really need to own up to their own mistakes and try to focus a bit more on our own commitment towards integrity and trustworthiness when we communicate science. So starting with the basic question that we have been having in this conference. So being a scientist, we can look into the human body in many different ways. So we can look into the systemic level of the body, we can think on the organ level, and traditionally, a lot of medicines were focused actually on the molecular level, so at the atom level. Nowadays, we are moving from that chemical perspective and going to the cellular and tissue perspective, and this is exactly where I also work. And thinking on the cellular and tissue level, we actually have moved from more traditional chemical therapeutics towards cell and gene therapies, which are quite more complex and raise quite a few ethical concerns. And one of them is the intuitive challenge of thinking on the boundaries between, for example, what is an organism and what is a model, what is a biological life and what are engineering systems, and what is a representation, which is what we create in a lab, and what is an identity, which is a completely different thing for us as human beings. So biomedical innovation forces us to rethink and redefine how we think on human in a society and in science. But establishing a bit more on the ground on where I work in, so for many years now I have been working in central nervous system diseases, and these are quite of a burden for society nowadays. So into 2021, around 3.4 billion people were suffering from one type of central nervous system disease. And these can range from, for example, Alzheimer's, Parkinson's, but other rare genetic disorders. And a big problem with these diseases is that we actually don't have therapeutic cures for them. And we can ask why. Why cannot we create? Science is advancing so fast. Why do we still have this setback? And this can be of diverse reasons, but the one that I focus on is actually a very natural reason. And this is a structure that we actually have, or a tissue that we actually have in our brains, which is the blood-brain barrier, or in short, the BBB. And this is a natural tissue, a natural tissue barrier that basically filters everything that we have from our bloodstream into our brain. And this is very good because it can basically hamper pathogens from trafficking to our brain, but it actually poses a major problem when we think on developing therapies, because the majority of them are actually going to be taken out of the brain also, or not taken out, but restricted from entering into the brain because of this structure. And of course, we can think that, okay, then let's study the blood-brain barrier to try to increase the translatability of our models, of our therapeutics. But then the problem comes another, which is the models that we use to study such tissues. And we have been already hearing a little bit on this on the conference, but there are different species that we use to study the brain. And in traditional neurobiology, we focus a lot on the mouse, for example, or fruit fly, or the zebrafish. However, as you can see by the illustration there are already quite structural and cellular differences in between the different animal models. And even when considering the mouse, which is the one that reassembles the most, the human, and the one that has been used quite extensively, there are molecular changes that really hamper from us to translate completely the preclinical results that we get from mice models into human. So we fall on this translational trap where the things that we are developing in animal models cannot really be translatable into humans. So here is where biotechnology has evolved quite a lot, and we have been more and more using, and the pharmaceutical industry also has put a lot of effort on trying to improve the models that we have, the human models, that are able to mimic a little bit better what we have in our human bodies. And one of the major breakthroughs that we had some years ago was the technology of the human-induced pluripotent stem cells, or iPSCs. These cells can basically be recovered from a skin biopsy or from blood that we collect normally or routinely in the hospital, and they can be taken to the lab, they can be reprogrammed, and we end up with a cell that is quite close to an embryonic stem cell, but that it surpasses the ethical concerns of using embryonic stem cells. And these have characteristics of pluripotent stem cells, meaning that we can use them to differentiate into the different tissues that we have in the human adult body, and therefore use them to study our new therapeutics. These cells can be used from patients, but also from healthy individuals, enabling us to study a series of different aspects, namely, for example, disease modeling, but also, again, for compound testing, and also for more complex therapeutics, so, for example, for cell and gene therapy. So this is quite important because, for example, one of the things that we can also do is in the lab, we can cluster these cells and we can form these three-dimensional tissue-like structures that can actually self-organize and have different cellular compositions as similar to the ones that we have in the tissue, and they can interact and function somewhat similarly to the tissue. So this is quite great, and we have been hearing a lot about these 2 days of these tissue-like structures, which normally are called organoids. And they are very critical because they can somewhat recreate physiologically faithful in vitro models of how the human central nervous system works. And they have been used extensively, again, for disease mechanism study, for toxicology, developmental biology. As yesterday we also heard from Professor Martin, for regenerative medicine applications, for drug discovery, infectious diseases, etc. However, these are just models. They are great, they have great potential, and they have been elucidating a lot of the questions that we once didn't know when basing our research fully on animal models. However, they are not the central nervous system. So a model is developed for a purpose. A model fits a purpose that the scientist behind it wants to illustrate. So for that reason, even the most complex central nervous system models that are out there to this day, they still have incomplete cellular diversity, a limited lifespan, absence of full body physiology, even if we can integrate the different organoids of different regions of the brain or of different parts of the body, and they show an incomplete function. And even if we look into the complexity, so in the scheme that you have in the slides, we have, of course, increased from the two-dimensional typical cell culture to the cerebral organoid. However, comparing the complexity and the different regions that we have of the cell organization between the organoid and the brain, this is very oversimplified. And this is, again, what I want to stress on this is that a model fits a purpose, fits a specific biological question, and should be understood as this. Because if not, we fall on the risk of misinterpretation. And here they are just a small example of some articles that we can find, not only in media, but also scientific articles that call, for example, these organoids, these cerebral organoids, as mini brains. And what I want to stress is that these cerebral organoids are not mini brains. They shouldn't be considered, and they shouldn't be entitled as such. Because if we start considering this, if we start entitle these models as mini tissues, as mini lung, a mini heart, a mini brain, in the general public, but also in the scientific community, we start making these exaggerated capabilities of something that is still just a model, that fits just a purpose. So we fall on this problem of the scientific accuracy versus the hype, so giving a lot more of what these models can do. We fall on this problem of the whole conscious human brain versus the consciousness of a model. And we fall in the problem of future potential versus the reality, and versus what we have up to this point that is not a mini brain. So more than anything, a model is like a mini piece of a puzzle that we use as scientists to try to fill in the complex puzzle that is our brains, but that is only a tiny little piece that needs to be understood even by scientists as such. So we are moving, and with this, we are moving from the most traditional ethics, where we focused, of course, on animal experimentation, patient consent, clinical risk, which are still very important, but that I think we also should a lot think on the ethics behind these misleading concepts of what are the models that are being produced in our labs. So we should avoid this miscommunication, because they can undermine the public trust, the policy decisions, and the responsible innovation. They can limit those. So what I want to say overall is that the trust is built when we communicate both power and limits. And this actually goes quite well to what we talked about yesterday, that being a scientist is actually being able to admit that I don't know. Even when I do a discovery every day, or not every day, of course, but even if I do a discovery at the end of my years of research, my feeling should be that I'm just opening another door of many unknowns. So I should never say that absolutely I trust this because I did it, but rather I should question it and always try to discover, because there is a world of undiscovered things that we should build upon. So 3 essential principles when communicating science for me are transparency, intellectual humility, and avoiding of oversimplification. And Just one last example is COVID-19, of course, taught us a lot of things, and one of those is not oversimplifying what it means to have a virus, what it means to be treated, for example, with a vaccine, but rather, for example, in this picture that was produced by the European Union, explaining what is a vaccine, explaining how it acts, and explaining what it's going to do in your body. And this way we can build public trust and indeed pass the concepts that we want to pass that are so important also for the people to know. So overall, the question for me of what it means to be a human, it's not reduced to biological components or experimental models or even engineering tissues, because even if science is moving towards that, that doesn't mean that we have representation of human dignity, consciousness, and meaning. So overall, the take-home message that I would like to pass is that, of course, these models, and specifically brain models, they are quite powerful scientific tools. They have helped us and foster a lot of great research, both in academia but also in industry. But it's very important that we have a responsible communication that could sustain public trust, collaboration, and engagement. So trustworthy neurobioengineering really requires revealing the power of our models, which is fantastic, but also their limits with equal honesty. Thank you so much, and I'll be happy to respond.
First of all, let me thank all our speakers for keeping the time so precisely. So we have 30 minutes available for debate, and well, you are the first one, second, and third. Where? Oh, okay. There is time for everyone. Please keep your questions
Professor
short.
Ioannidis, thank you for your disruptive lecture, important and disruptive. However, I still believe or hope that the scientific community has the antibodies to resist to this frightening perspective. But I would like to touch on another point. As John Paul II put it, technology is moving too fast for our culture to respond. We have a society dominated by technology, in association with the loss of prestige of science that you have mentioned here. Because there is a loss of the culture of science. Science is embedded in our culture. And when we in our institute, we organize open days with the schools. Students in the Italian high schools, when I ask these students, what is the difference between a therapy or a compound which has been developed through scientific research and anything else you can find in the web? They don't know. So I think we must acknowledge this issue and that we all share the responsibility to do something.
John?
I think that these are very fair and insightful comments, and obviously the antidote to these problems is not anti-science or ignoring science or throwing science away. Science needs to find still the stamina, the strength, the resources, the tools to self-correct itself as it has been doing, since the very beginning. Science starts with falsifiability, starts with the possibility of being wrong, of having errors, of trying to find them, fix them, reduce them. So yes, in terms of the practical question that you ask the students, it's important to teach the students that the difference is that there's a scientific method process that, we test things and iteratively we go through phases of discovery and experimentation and evaluation and validation, and then hopefully we get some effective treatments, and in some cases they save lives, they extend lives, they improve quality of life. At the same time, I think it's important to teach both the students and the average citizen about the challenges, about how difficult it is to do good science. It has always been very difficult. And I think it continues to be perhaps even more difficult despite all the technological tools, because it's very easy to be misled and misguided and just fail, not despite the technological tools, but because of the technological tools. You know, I see myself and many other colleagues who are supposedly methodologists. You know, the onslaught of AI can get you completely distraught and off track. And you can do weird things, wrong things that you wouldn't have done otherwise if you had the slower tempo of, well, I will learn one step at a time. Now you learn within 1 second, and you learn everything. and it's impossible to absorb everything within a second. So if you look at the Cochrane database that summarizes what evidence we have on medical interventions across all sorts of interventions, only about 5% of medical interventions have strong evidence that are effective. Now, it doesn't mean that others are not effective. Some more are, but their evidence is not so strong. It could be weak, and in many cases we know not enough about their adverse events, the balance of benefits and harms. So we want better evidence, and unfortunately this embarrassment of riches of technology is not necessarily helping us, because it's a constant temptation. What I used to say is that now we have tremendous ability to measure very quickly, very fast, very broadly, very detailed. Most of these measurements are a waste of time. You know, in the past, if you wanted to study, you would say, oh, I need to come up with an important scientific question. Okay, what is an important scientific? I'll study dust. Not a very important question, but who knows? You know, maybe dust. So what I would study with dust, you know, pretty much what I would get with a vacuum cleaner, what is the weight of dust in the room? Well, then you could measure 10 things, you know, 10 features in the dust. Then technology allowed you to measure 1,000 things. You know, now we have technologies that we can measure 1 billion things in the dust. But we're still measuring dust most of the time. And you know, it's so fascinating because we get 1 billion measurements, and you know, people like me, I love numbers. You know, give me more numbers. 1 billion measurements on dust. You know, I'm happy. I'm wasting my life. I'm wasting my science, my research, and your taxpayer money on studying dust. So I think we need to be fair and honest about that. That people like John will study dust. That's too bad. But there will be some other that will do the right thing and will find something that will save lives or make lives better. Not give the impression that everyone is just doing great and science is powerful and innovation and disruption, because that's not true.
Yeah, just a brief comment. I will not talk about dust, neither about students, but mostly about this gloomy picture scientific research. This is a very, very complex problem that we have now, and complex problems do not find single solutions. So we have to put on our table a lot of variables to take into consideration and see how they play. You said that universities were not leaders on research anymore, but centers of different research fields. And also, public the research is not on public, receiving from public money is not public in public institutions. Is mostly in private institutions. We talked about that yesterday. You remember that it was said that the young students, medical students, or medical or already young medical professionals were aiming to go to public healthcare facilities instead of private, and that can give us a little bit of hope, because one of the problems that we have with the situation here today in science is that it's financially driven. It's not only the question that you said in democratic countries or not in democratic countries. That was important before, because democratic countries would assure the creativity and the freedom to create. But now what is more important is really financing. And non-democratic countries can finance heavily specific lines of research. So it's most of these private research centers are in the stock markets. So they deal also with communication to raise the stock market. So this is an important variable that we have to take into consideration. So if we push more public investment into research, we might promote the common good instead of only profits.
Sorry, we have a problem. 10 minutes for the first question and still not less than 4 other questions. My suggestion is please present your questions as short as possible, and then we leave the floor to the speakers for their final comments. Can it be okay for all of you? So.
Yeah, I think this is, thank you again for your presentations. That was wonderful. I just want to make sure everybody in the room realizes that this is not just science's problem. So a few years ago at the American Society of Bioethics and Humanities, the wisdom figures of the group got up and said, bioethics is no longer about philosophy. It's about advocacy. And I think that's our problem today, is so much is being pursued for a particular purpose that doesn't necessarily align with what that activity is. So we're not doing science for science's sake anymore, or to help people. Common good is gone. Science is for profit. And if you are honest with the public, you will have a very short career in science. Sorry about that. But I think the same can be said for philosophy now and theology. And sorry, Maria, but so this is, I think, one of the struggles that we all have is that, as you said, there's so much money driving everything, but that money is very focused by different groups on different ends that don't align with our goals.
Second one?
Thank you, Ioannidis. I have also another point of observation, which have to be clarified. We have the impression there is a mafia inside to the publication system. And this is touching also the development of science. When I was fighting against Women Health Initiative and trying to publish some papers demonstrating the safety of hormone therapy in postmenopausal women, I was defeated by the system. I spent 4 years to publish a paper which went after in an European journal, but I was unable to publish an American one, starting from endocrine reviews, because that mafia was convinced that they were right, independently from scientific data. I was touching them. You have the study telling menopause therapy, it was not a menopause therapy. And then it was impossible to publish it. I went to JAMA, it was impossible to publish it. When I went to a European journal, I had access and we published at the end. And this is also something strongly disappointing for us, which we are living in the old continent. And the last point observation is now the open access system. The open access system have made a revolution, because only those who have the money that you were mentioning, they can publish, not our students, because we cannot support 5, 6, 7 papers in 1 year, paying $3,000, $4,000 each. Thanks a lot.
On the other side of the room.
Yeah, I try to be very, very quick. I have 3 questions, but very quick. So the first for Maria. Since visualization is becoming so important, people access knowledge through videos and audio. And so how can we improve research visualization from your opinion?
Catarina, not Maria.
Catarina. Oh, sorry. Sorry. Yes, and then Maria Neves, I wanted to ask you, you made the difference between therapeutic and enhancement, and I had the impression that it becomes more and more difficult to distinguish, and that we have more room for enhancement, and this is increasing. So would it, and that it leads to an attitude of full availability of everything, and do we need an ethics of discomfort or even of degeneration to be able to deal with this increasing possibility of an enhancement? And the third question, just very quick also, because you raised the question this morning about the quantification of spirituality. Is it possible to put everything, every existing bit transported in an information unit? And when I understand you right now, I would say it is rather a problem trying to quantify everything, this idea of datafication of knowledge, which leads only to an increasing of data. And do we not need more quality, if I understood you right?
I saw you.
I had a question about it. So there is a lot of attention for peer review, but I was wondering, what do you think is the role of academic institutions? I mean, we were talking, there was talk about organoids, and you come from Stanford, where there is a big hype also on organoids. And I believe that all institutions know perfectly who are the individuals that are overstating and overselling and so on and so forth. So what do you think is the role of academic institutions in trying to, make it, at least make those individuals aware that, maybe that's not best practice?
Any other question? So, okay, maybe we... please, the last one. There.
I'm touring the world. I'm an anthropologist, physical and cultural. I've been teaching at the State University La Sapienza and also Catholic University. And now I'm retired and I'm touring the world. I'm coming now from a month in China, and before I was in the United States, always about the subject of Maria. So the enhancement is overpassing, totally overpassing, and the advocacy of is number one. All the rest, and since I've been consulting Radio Vaticana, I was working here for the Secretary of State, Sodano, and I think we are very, very behind because the Chinese army and the U.S. army are studying secretly announcement so much, so far, that I consider myself working for the Italian government and the Vatican, and we are much behind that.
So we can take the reverse order. So, Catarina?
Okay, tough.
We have 13 minutes.
Yes, so an overall comment is that I think that we need to take, and of course this is not just a problem of the scientific field, but I speak for myself at least as a scientist, and I think as a young scientist, I really think it's good that we start thinking about these things early as our careers. Because even today at lunch we were discussing that many times these ethical problems and our consciousness regarding ethics only comes very, very later on in our careers. So I do believe that if we teach our young minds to think about these questions, think about how science can be a bit more approachable in the different lenses of science communication, we can start speaking each other's language much more easy. And science community, at least from my very narrow eyes, of course, has been quite closed within itself. So we speak about science in science conferences, we write science in scientific papers that are not shaped for general public. So now conferences in the scientific community start having more patient associations, for example, present, etc., but it's still a drop in the ocean. So we are making efforts, but not enough for sure. So I think that if we start having these ethic conversations in universities, but then we pass them also for the labs in the more scientific round, so in our day-to-day, I think we are going to go towards the science that it's a little bit more transparent and a little bit more accessible also to people. Because if not, people just close and just think that we are just people that are know-it-alls and they don't try to accept us. So I really think that it's part of our responsibility, and I feel it a lot on trying to show my science as clear as possible so that of course, nobody is going to understand all of the single details, but at least that I try to pass the message that people can understand. And just the last point regarding the science illustrations or the science communication in terms of visuals, I think they are very, very, very important. And I think that there's a lot of, we are paving our way towards having a more unified way of presenting science. And this has been brought by different companies that have thrown out there scientific illustrations that are a little bit more easy for scientists to use, but also for the general public to understand. So for us to make science accessible also through visuals, it's also easier for people to connect with us and also to understand more easily what we are working. So without a doubt that making science accessible through visual, schematics, illustration, movies, etc., it's a way of reaching the public that is much more appealing than a scientific manuscript, which is incredibly dense and sometimes even difficult for us scientists to understand.
Thank you. John?
Well, amazing questions, and I think I will try to connect all for five of them, because everything is connected. You know, everything is interrelated. Institutions are critical in determining incentives, in determining the reward system, who gets recruited, who gets promoted, who gets funding, who gets supported, who can go to the dean's office and get some extra support. Conversely, who is censored, persecuted, not allowed to do his work, his life made miserable, or all of that. And that can be determined or shaped by commercial conflicts, financial conflicts of the university. You know, you go big universities advisory board, all big tech and big pharma people, board of directors, board of trustees, again, billionaires, CEOs, CFOs, COOs, UFOs, So yes, I mean, one can say one can fight the battle at the institution level, but it's all interconnected. Advocacy, clearly a big issue. And as I said, advocacy and activism could be for the right cause. And in some of the fields that I work, like public health, I go to the public health meetings, and all the talks are, we need activism, we need advocacy, we save the world, we save lives. Okay, yeah, yes. Are you activist enough? Yes, I'm a scientist. You're an activist? No, or yes, otherwise out of here. So it's a, we need activism, but it has to be very transparent. Now, this is Ioannidis talking as an activist, okay? Treat me as an activist. Now, this is Ioannidis talking as a scientist. If I decide to have this schizotypal type of personality, otherwise I might say, I want to be a scientist, please. But that's not easy nowadays. Mafias. There's many mafias out there, and 40 million scientists. If you divide them into mafias, maybe there's tens of thousands of mafias. They change all the time. One mafia fights the other. The one barbarian tribe replaces the other. It's like the hordes driving the old hordes out, and it's a mess. In some fields, it's more a mess than in some others. Now, some of that animosity and contrarianism is not necessarily bad. I mean, because science needs contrarianism. It needs someone to come to me, John, you're completely wrong, okay? I may be completely wrong. I don't expect my papers to be published in JAMA all the time. Some might. Many, oh my goodness, I don't want to count my rejections. The number is astronomical. That's fine. That's fine, provided that there's still the opportunity for you, for me, for others to publish and to be criticized that this is wrong or this is correct. And data versus quality. I don't want to sound like the answer is we trust in God, and this is the Vatican, everyone else should bring data. This is the standard motto. Now, data includes quality. Qualitative assessment, qualitative research, qualitative science is amazing science, extremely important. Are we undervaluing it? Yes, we are undervaluing it. It's so much easier to just buy a chip for $5.99 and get 1 billion measurements, compared to do a qualitative study where I need to design it for 3 months, pilot it for another 6 months, test it for 2 years, and then analyze it slowly and have 4 years of failures to publish it. So we can do more qualitative work. We can do better qualitative work. I have to say, a lot of qualitative work is not very good quality. And I mean, we've repeatedly shown that qualitative work can be reproducible. My colleague Tamarine de Haven has written some very nice papers about reproducibility of qualitative research. So we need more of that. But I'm not sure whether I missed. Yes, and you know, your experience is very much aligned with what we were saying about activism and advocacy. And each field is having a different set of problems. There's some convergence, some common problems, some uncommon problems. I think you need to ask the scientists in their field, what do you think are the main issues? You need to do some piloting, some validation, some reproducibility checks, like what happened in the SCORES project, to try to understand what's going on here. Where are we and where are we heading?
Thank you. Luigi? Nothing to add. I say, what can I add after John? Well, from my point of view, one point I was trying to ask to John, there is also problem in evaluation of a scientific paper. I mean, when I used to front to say impact factor or H index, okay, and that's a problem. But there is another problem, new problem, in my opinion, that is altmetric. I don't know what you think about altmetric. I think that it's a very, very misleading index. I don't know what you think about.
Oh, I love altmetric because I have some of the highest altmetric scores in the history of science.
That's a good reason.
Yes, I'm highly conflicted. And they also led to many death threats against me, my family, everybody. So no, I'm kidding. No, I'm not kidding. That is true, unfortunately. No, I mean, people brought altmetrics in an effort to dissociate from the dominance of impact factor, try to get social visibility and media presence and social media presence. They're measuring one aspect of, how much research is discussed out there in the community. But being discussed does not mean that this is good research necessarily. It doesn't mean that it is research that changes the world in a positive way. It doesn't mean that those who discuss have any clue about what they discuss. Most of them have not read the paper. They just saw it mentioned in their influencer who they follow. And the influencer was saying, kill John Ioannidis. And then, everybody kill John Ioannidis. And who is John Ioannidis? Oh, he must be a rock star something. They don't even know what this is about. And then I get the highest altmetric scores. So it has to be tempered. It has to be interpreted. It's another tool, one measurement. That's all it is.
Well, during just I had just a few things. Well, during the COVID era, when me as a journalist, I was facing with altmetrics, it was a problem for me because altmetrics was read not just by scientists, but journalists. A journalist take something about public on bioarchive or medRxiv, not peer review. Maybe rejected a few days later, and it became a title, and it was frightening for us, terrible, because we are looking to stop. No, please don't do it. Don't do it. We saw something, an example like hydroxychloroquine or DNA inside HIV DNA inside SARS-CoV-2, and it was not true, but it became a line, and I have to fight in my journal. Please don't do it. Don't do it. Be responsible. And it was a problem. Altmetric was giving great success to this kind of situation because everyone read it. So
it's a signal. It just says that people are talking about it. Whether they know what they're talking about and why they're talking about, we don't know. But they're talking about that's all we can say. And then it could be completely wrong. It could be completely wrong. And if you feel a responsibility to kind of attack or criticize something that is completely wrong, you can go there and check these allometric scores and say, okay, these are the 10 top papers today, and are they sensible, reasonable, interesting, contributing, or completely very wrong, and things have gone completely astray. Are we able to tell what has gone astray in real time? Unfortunately not. I mean, you may ask the best experts, they will be wrong much of the time. You know, they will say, no, it's completely wrong, and then 3 months later, the paper will be validated. Conversely, something may be thought to be correct now, and 3 months later. So some epistemic humility, some sense of, don't jump the gun, a little patience, a little calm. And I mean, the pandemic was very clear, an example. There was no calm, no one wanted to wait with good reason. And everybody was in a state of just kill your opponents, or everything is wrong. It's not easy. I mean, I think science is very difficult. Journalism, oh my goodness, it's 10 times more difficult.
Maria.
Yeah, thank you so much. I would love to comment on all the questions that have been addressed, but of course it is impossible at the time. But I would at least say a sentence about each of them. But bioethics advocacy, I would say that, yes, of course, I totally agree with you. I would rather see all the energy and emotion behind advocacy in talking with confidence and building trust. We could just go use that energy to talk in such a way that we can really build trust on the others, and it's not through advocacy, of course. About publisher, the mafia in the publishing world, well, there are so many examples. The one that you presented is mostly about financial or non-financial the publication, because we know that only those that receive huge grants can really publish in very high-level journals. And it doesn't mean that it's the best research. It's the healthier research, the one that continues to be published and continues to be quoted. It doesn't mean that it's the best one. And what about good researchers from Africa? Where can they publish? Well, they have to join North American or European researchers team, but they stay in the worst place in those dozens of researchers. So there's so much to say about that. Allow me to focus on the enhancement question. What I said was precisely that the distinction between therapeutic or enhancement purposes, it's really fading away, so it's not really useful. Do we need an ethics for that? We need ethics, point. I mean, we need to think ethically about scientific progress and technological innovation. We also need to know why are we far behind, and we are far behind from what exactly? That is my question. I heard Margaret Vertrouwen. I don't know if you remember her. She was European Commissioner, and I heard her talking last October in Copenhagen, and she said something that was really music to my ears. People keep saying that European Union is behind the others, but that was about AI, and that the others are taking the lead, and we are running after them. But where are they going? Do we really want to take the lead? And my question that is a little bit different now is, do we really want to go the same way as the others? Because listen, if we are in the same race with the United States or with China, come on. We're going to lose it anyway. But is that really what I want? I want the kind of research that it's being done so far in these countries? Or could we find another model of doing research? Take AI, for instance. Nowadays, Europe is investing a lot in digital sovereignty. What does that mean? It means that we are trying to create a model for digital technologies that is grounded in human rights, that is embedded in ethical requirements, that is responsible socially. So it's an alternative, is another way. So I'm not sure if my major concern is to be behind the others, or if I really have to choose another model of doing things. And perhaps that new model of doing things can become a paradigm for others. Perhaps I can join not China or the United States at the current moment, but perhaps Africa, South America, Asia, Australia. Perhaps they prefer our kind of model that is respectful of human beings instead and of human rights, instead of other models that are just profit-driven. So, yes, I'm still on my 5 minutes, okay? And I really need to express, because this is a way out of this gloomy idea that we are almost sinking. So we have to finish with another way of going forward. So I think that instead of running behind the others, it's better to see if there is another model that we can really invest. And the last point that is connected to this one is to create legitimacy for regulation. Regulation is an enemy currently in the United States as in China. It's not here. But there are so many other people here in Europe that won't deregulate. I don't think it is possible to, without having regulation, to make sure that the benefits of scientific research will be distributed by all, that all society will benefit from research. So only regulating it in a balanced way, fostering innovation, but making sure that there are some boundaries, then we can really create the right conditions for the benefits of research to be distributed by all. But in order to have regulation, we need to legitimate that regulation. That is, building the consensus in the society, have an inclusive dialogue, and then also the citizens will be behind the regulation or even in front of regulation saying we need it if we really want to be co-workers, co-creatives of scientific research. So that is really what I'm looking for nowadays. Thank you.
Thank you. Just to highlight some of the points that are worth further debate and reflection. It is about public trust, policy decisions, and responsible innovation, which are the pillars, both the pillars and the goals of our social and political communities. It is about professional duties. It is about epistemic humility. I like very much this point, and it is about regulation as a tool for promoting inclusion and not to stay behind. And finally, maybe there is also another issue which is worth reflection for a community of, well, may we say, friends like this one. Open access, I like it very much. There is open access for readers. This is good. But what are you doing to promote open access for researchers, especially those coming from not lucky countries? This is really a crucial point for the future. So we deserve a coffee break. Maybe Ralph and Renzo will allow us 15 minutes, even though we are some minutes late. Thank you very much.